Good afternoon and welcome to another session in our Learning Together program. On behalf of the Brosis Brother-Sister Foundation, I welcome you to an opportunity to expand your knowledge in mathematics. And today we're going to be working with expanding binomials and introducing factoring trinomials. And then next session, which will be Thursday, we'll take it to a little bit more advanced. But to start, the word expand means to make bigger. And what it usually involves, or what's often the case, is that you end up multiplying algebraic expressions. So I'll start with something simple, and then I'll build it up further. But keep in mind, I need you to look for patterns, because if you can see the patterns, it's going to help you when we get into factoring, because there is a connection, a direct correlationship. So you have to be able to see what's happening when we expand, because factoring is the reverse. It's going in the opposite direction. So we'll start by doing some examples with expanding. So if we had, say, 2 times x plus 5, this means 2 times everything that's inside the parentheses. So everything has to be multiplied by 2. So we end up with 2x plus 10. If we had, say, 3x times 4 minus 5x. This is a little bit more involved. What is here is 3x, and we're multiplying 3x times whatever is inside. So it's going to be 3x times 4 gives me 12x, and 3x times negative 5x, a positive 3x times a negative gives me a negative, and 3 times 5 is 15, and x times x is x squared. So again, we multiplied everything and we ended up without the parentheses. When you expand, the parentheses disappear. So let's try another one. If we were given, say, x plus 2 times x minus 4. Now we have a binomial that's 2 terms times another binomial 2 terms. So it's everything here times everything over there. So this takes a little patience. It's x times everything plus 2 times everything. And then, if possible, we combine like terms. So x times x gives me x to the 2nd power. X times negative 4 gives me negative 4x. Positive 2 times x gives me positive 2x. And positive 2 times negative 4 gives me negative 8. So I got 4 terms. But when I look at the 4 terms, I realize that the 2 middle terms can be combined. They have x to the power 1, x to the power 1. So we say they are like terms, so we can do the combination. So we now end up with x squared, negative 4x plus 2x is negative 2x minus 8. So this is the expanded version of this. And I'll just give you a hint. If you were asked to factorize this, you would end up getting this. So for the beginning, we're going to go from left to right. And then near the end, we're going to do the reverse. And we hope we can see the pattern. Okay? Let's try another one. If we had, say, x minus 5 times x minus 3. What will we end up with? X times x is x squared. x times negative 3 is negative 3x. So we're finished with multiplying x. We multiply x times both items. Now we're going to multiply negative 5 times both items. So negative 5 times x gives me negative 5x. And negative 5 times negative 3 gives me positive 15. Again, we have two middle terms that are x to the power 1. So there are two linear middle terms. So we can combine them. We end up with x squared minus 8x plus 15. Again, if you are asked to factor this expression, this trinomial, we would end up getting these two binomials. Okay? Let's go. So you may be asked, what is x plus 5 to the power 2? If you're asked to expand that, you would say, oh, okay, it's equal to x plus 5 times x plus 5. The square means that we multiply it by itself twice. So we end up with x times x is x squared. X times 5 is 5x. So we're finished with multiplying by the x. So now we need to multiply by the 5. 5 times x is 5x. 5 times 5 is 25. Put these two together, we end up with x squared plus 10x plus 25. So it seems pretty straightforward. I would like to take this time to mention a very common expression that is used in math world. It's called FOIL. That's a mnemonic which is something used to assist you to remember, help you to recall. So what does it stand for? Well, F O I L. Says F is for first, O is for outer, I is for inner, and L is for last. You must be wondering, what on earth are those four things dealing with? We have first, outer, inner, and last. Okay, last is right there. Okay, good. So I need to show you, using an example, how these letters are used. But even if you do not know the word FOIL or the expression FOIL, you will be able to expand. It's just that if somebody was to say FOIL it, I want you to know what they're asking you to do. All they're asking you is to multiply one binomial times another binomial. But I'm going to illustrate to you how these letters come into play. So remember the four words: first, outer, inner, last. FOIL. First, outer, inner, last. Okay. So if you had A plus B times X plus Y, the first term in this binomial is A. The first term in this binomial is x. That gives me ax. The first term in this binomial is a. The first term in this binomial is x. A times x gives me ax. That's the f order. This is the expression, what's on the outside here and what's on the outside there. This is a on the outside to the left. This is y on the outside to the right. So it's a times y equal to a y. So it's a times y. So now we're finished with a, and now it says we use I. If O is outer, I is on the inner, is inner. So what's on the inner side of this binomial? B is on the inner, X is inner, they're on the inside. So it's going to be B times X. And then finally, last. What's the last term for the binomial, the first binomial? B is the last term. What's the last term for the second? Y is the last term. So it's going to be B times Y. So the result is AX plus AY plus BX plus BY. Again, even if you never heard the word or the expression FOIL, never heard it before, that's what it stands for. So now you know what it's referring to. So if somebody mentions it, you say, oh, I know what that is, okay? You could still multiply those together without knowing about FOIL. Okay. I also like to take the time to show you that there are some teachers who teach you to multiply algebraic expressions using a box. So for example, if we have 2x plus 5 times x minus 4. You put the 2x right here, you put the 5 right here, you put the x right here, and you put negative 4 right here. So what have we done? The 2x is here, the 5 is here, and then the x is here, and the negative 4 is here. So 2x times x is 2x squared. 2x times negative 4 is negative 8x. Now come to 5. 5 times x is 5x. 5 times negative 4 is negative 20. So again, I'm just showing you another way that some people do the expansion. So what is the result? It is equal to 2x squared minus 8x plus 5x minus 20. Again, I'm showing it to you, so if you see it in a book, you know what's happening, okay? So that's equal to 2x squared minus 3x minus 20. Okay? And of course, if this was extended to involve not just binomials, but say, for example, a trinomial, you just do the same process. For example, if you had, say, x minus 2 times 3x squared minus 4x plus 5. So now you have a binomial times a trinomial. You could say, for example, write x minus 2 is here, and this is 3x squared, this is negative 4x, and this is 5. So it's x times 3x squared gives us 3x cubed. X times negative 4x is negative 4x squared. X times 5, 5x. And now we have the negative 2. Negative 2 times everything. Negative 2 times 3x, negative 6x squared. Negative 2 times negative 4x is 8x. Negative 2 times positive 5 is negative 10. Doing it using my way, it's going to be x times 3x squared, 3x cubed. X times negative 4x, negative 8, negative 4x. X times 5 plus 5x. Negative 2 times 3x squared is, well, x times 4x is 4x squared, sorry. Negative 2 times 3x squared is negative 6x squared. And negative 2 times negative 4x is 8x. Negative 2 times 5 is negative 10. Put it all together. 3x cubed, there's only one term with x cubed. There is no other term with x cubed, so therefore this is by itself. Now, negative 4x squared minus 6x squared is negative 10x squared. We spent time before dealing with negative and positive numbers. That was for a previous session. So we are very good with our negatives and our positives. So 5x plus 8x is 13x. And then negative 10 is by itself, negative 10. From here, we get the same result. 3x cubed, there it is. This and this, negative 4x squared, negative 6x squared, negative 10x squared. 5x and 8x, 13x. And negative 10, negative 10. Same result. I need to do one last thing with this, and then I'll go into factoring. Suppose you were asked, what is x plus 4 times x minus 3 times x plus 1. So we are multiplying 3 binomials. How do you do it? Well, if I gave you 5 times 2 times 3, you could say, okay, 5 times 2 is 10, 3 times 10, 30. Or you could say 2 times 3 is 6, 5 times 6, 30. So you multiply 2 first, then you multiply by the third. Same thing right here. You be very patient. I would multiply the last 2, and then whatever I get, I multiply by the first binomial. So I will put this equal to x plus 4 times x is x squared. x times 1 plus x. Negative 3 times x, negative 3x. Negative 3 times 1, negative 3. What did I do? I multiplied these last two binomials first. X times x, x squared, x times 1, 1x. Negative 3 times x, negative 3x. Negative 3 times 1, negative 3. I can simplify these two, so I'll write this as x plus 4 times x squared minus 2x minus 3. And now I'm going to multiply by this binomial. I'm going to multiply this trinomial by this binomial and combine like terms. So I end up with x times x squared, x to the third. X times negative 2x, negative 2x squared. X times negative 3, negative 3x. So I'm finished multiplying by x. Now I need to multiply by the 4. 4 times everything that's over there. 4 times x squared is 4x squared. 4 times negative 2x, negative 8x. 4 times negative 3, negative 12. And now I'm going to look if there are any terms that I can put together, any like terms. So we now have x cubed is by itself, but I see that this negative 2x squared plus 4x squared gives me positive 2x squared. I see negative 3x and negative 8x, that's equal to negative 11x. And then finally, negative 12. So by multiplying these two and then multiplying by the first one, this is what I'm getting. X cubed plus 2x squared minus 11x minus 12. What I'm going to do is this. I'm going to write this answer right here, and I'm going to do the same question, but this time I'm going to multiply the first two and then multiply by the third. And let's see if we end up with the same answer. So let me take a minute, and I'm going to write the answer down. So it is x cubed plus 2x squared minus 11x minus 12. Let me check my answer, my work first before we do the second part. Let's go. X times x, x squared. X times 1, 1x. Negative 2 times x, negative 3x. Negative 2 times 1, negative 3. Put these together, negative 2x. X times x squared, x cubed. X times negative 2x, negative 2x squared. X times negative 3, negative 3x. 4 times x squared, 4x squared. 4 times negative 2, negative 8x. 4 times negative 3, negative 12. Combine x cubed. This plus that is 2x squared. This minus that is negative 11x, and that's 12. Yes, that is correct. So now I'm going to clean the board and then work using the first two and see if I end up with the same result. Okay, so what do we have? Well, x times x is x squared. So I'm multiplying these two. X times x is x squared. X times negative 3, negative 3x. Now 4 times x, 4x. 4 times negative 3, negative 12. And then when I'm finished, I'm going to multiply that times x plus 1. So I'm multiplying the first two. I got x times x, x squared. X times negative 3, negative 3x. 4 times x, 4x. 4 times negative 3, negative 12. And I have x plus 1 at the end. So let's simplify these two. X squared plus x minus 12 times x plus 1. Now I'm going to multiply this trinomial times this binomial and then combine like terms. X squared times x, x cubed. X squared times 1, x squared. X times x, x squared. X times 1 plus x. Negative 12 times x minus 12x. Negative 12 times positive 1, negative 12. Combine like terms, if possible. X cubed, no match, so it's x cubed. X squared plus x squared, 2x squared. X minus 12x minus 11x. And minus 12 minus 12. Is that the same result? X cubed, 2x squared, negative 11x, negative 12. Same result. Perfect. Okay? So, if we had a situation in which you had 4 binomials, then what could you do? You could go through using the same process that I've done, where you multiply 2, then you multiply the third, and then you multiply the fourth. Or you could multiply 2 here, multiply the first 2, and then multiply the results. It will still work itself out, and you will still get the same result. Okay? So, this method of expanding where everything is just going across like that is called the linear method. This is called the linear method. But then there's also what is called the vertical method, which we'll discuss. Okay? So what I'm going to do now, I'm going to do an example that does not involve binomials. It involves trinomials, because I want to make a point and show you something that might be very useful with more complicated expansions. So this is, again, this is an exception. But let's see what happens. If you had, say, 2x squared minus 5x plus 3 times 4x squared plus 6x minus 2. If you're asked to, let me get this off the floor. Beautiful. So if you're asked to expand that, so you have a trinomial times a trinomial. I said to you that there are 2 methods, but actually there are 3. You could use the box, you could use the linear, and I'm going to show you a vertical approach, okay? So we're going to do the linear first, and hopefully we get the same result when we do the vertical. So here we go. 2x squared times 4x squared is 8x to the 4th. 2 times 4, 8. X squared times x squared, x to the 4th. 2x squared times 6x is plus 12x cubed. 2x squared times negative 2 is negative 4x squared. So now I'm finished with the 2x squared. I'm going to go to the negative 5x. Negative 5x times 4x squared is negative 20 x to the 3rd. Negative 5x times positive 6 is negative 30 x squared. Negative 5x times negative 2 is positive 10x. And now we're going to multiply by 3. 3 times 4x squared is plus 3 plus 12. 12x squared. 3 times 6x is plus 18x. 3 times negative 2 is negative 6. I like to check my work just in case I make a mistake, I like to check. So let's check. 2 times 4, 8. X squared times x squared is x to the 4th. 2 times 6, 12. X squared times x, x third. 2 times negative 2, negative 4x squared. Good. Negative 5 times 4 is negative 20x cubed. Negative 5 times 6 is negative 30x squared. Negative 5 times negative 2 is positive 10x. Good. 3 times 4, 12x squared. 3 times 6, 18x. 3 times negative 2, negative 6. I'm very comfortable with my result. And so this is going to be equal to, there's only one term with x to the 4th. So I can go ahead and write 8x to the 4th. Now, what about x to the 3rd? We have 12x to the 3rd minus 20x to the 3rd. That gives me minus 8x to the 3rd. So now let's go for x squared. Negative 4x squared, negative 30x squared, and 12x squared. Negative 4, negative 30, positive 12. So this is negative 34 plus 12 is negative 22. What about x? There is 10x and there is 18x. So that gives me positive 28x. And then there is negative 6. So that is my result. Okay? So I'm doing the linear. Linear means you just keep going across, then down to the next line. That's the linear approach. The vertical approach is different. So we're going to try that. But before I do that, I need to write this answer down so we can have it to check our result. So let me write it down and we'll see. So it is 8x to the 4th minus 8x cubed minus 22x squared plus 28x minus 6. So that's the result I'm hoping to get when I do it using the other method. Okay. The vertical method says that you line up like terms vertically. So here we go. 2x squared times 4x squared is 8x to the 4th. 2x squared times 6x is plus 12x to the 3rd. 2x squared times negative 2 minus 4x squared. So we have 3 terms, x to the 4th, x to the 3rd, x squared. Now we're ready for this. Negative 5x times positive 4x squared gives me negative 20x cubed. This time I write negative 20x cubed. I write them right underneath each other. Negative 5x times 6 is negative 30x squared. Negative 5x times negative 2 is positive 10x. See? X cubed, x cubed, x squared, x squared. This is one term only. That's one term only. So it's vertically lined up. One more to go with the 3. 3 times 4x squared is 12x squared. So I need to write that underneath this. So it's positive 12x squared. 3 times 6x is positive 18x. 3 times negative 2 is negative 6. And now, to finish the job, we draw a line and we just we just go vertically. 8x to the fourth is by itself. Now, positive 12x cubed minus 20x cubed is minus 8x cubed. Negative 4x squared minus 30x squared is negative 34x squared, plus 12x squared is negative 22x squared. 10x plus 18x plus 28x, and then minus 6 comes right there. What is the advantage with this? When it is linear, you have to be looking to see which ones match. When it is vertical, you already can see the terms that are like terms lined up to each other already vertically. So you just have to just combine them just as they are. It's easier to combine like terms. With the horizontal, the linear or the horizontal method, you could miss terms by trying to pick because they're scattered all over. Whereas with the vertical, they're lined up perfectly already. That's a big advantage. Nothing major, but for me, it helps me to organize my terms easier. Okay? So that is for expanding, and it doesn't matter how many terms or how many set of parentheses you have. Just go step by step, by step, by step. It will work out at the end. Okay? So now we have expanded. Now we want to factor, which is to combine, bring it into parentheses. Okay? Okay. Just a little vocabulary. If I give you x plus 6 times x minus 3. Let's not use minus 3. Use, say, x minus 4 equal to x squared plus 2x minus 24. That's what you will get if you do that. This is called the expanded form or standard Remember, we discussed in a previous session that standard form is when you write the terms from the highest exponent down in decreasing order to the lowest. So this is the expanded version of this, and it is in standard form from highest to lowest. This is called the factored. In other words, this expression is written as something times something as a product of its factors. When you multiply this times this, you get that. So the part where you have it in parentheses with the multiplication is called the factored form. When you get rid of the parentheses and write it from highest to lowest, highest exponent to lowest exponent, it's called standard form, or it is an expanded version of this expression. Okay? So what we're going to do now is I'm going to introduce us to how we go from this section, from the right to the left. Pretty cool, it's pretty neat. So stay with me, okay? We're gonna go from the standard form to the factored form. Here we go. So today we're going to do some easy ones, and then next session we're going to do more complicated ones. So stay tuned. Okay, let's start with something simple. If we had, say, 3x squared minus 7 minus 27. What's that equal to? Well, let's minus 27. Let's go simple. 3x minus 27. If I ask you to factor that, all you have to do is to look and see if there is something that can be divided into each expression without a remainder. And in this case, that thing is actually the number 3. It is called the GCF. GCF, which means the greatest common factor. So if I factor out a 3, what's left? When I factor out a 3 from 3x, we have an x that's left, because look at it. 3 times x will give me the 3x. The sign is a minus sign. I can put a minus sign. If I factor out a 3 out of 27, I'm left with 9. So this is the factored form of that. We can't go any further with that. That's the best we can do. The best that we can take out of this is a 3. Okay? Let's try another one. Number 2. If we had, say, 4x squared plus 20x. What is the GCF? What is the greatest expression that you can get out of both this and that without a remainder? So for 4 and 20, the number that you could get is 4. But there's an x squared and there's an x. So x is common to both terms. So I could actually take out an x as well. So I'm saying to you that I could take a 4x from here and I could factor out a 4x from there. So if I factor out a 4x from here, what should I put inside so that when I multiply, I will end up with 4x squared? And the answer to that is going to have to be x. Let's check. 4x times x is 4x squared. What is the sign here? It's a plus. Okay? Now, if I factor out a 4x from here, what number should I write here so that when I multiply 4x times that number, I end up with 20x? And the answer is 5. So the GCF is 4x, and what is left inside is x plus 5. So 4x times x plus 5, I'm saying is the same as this. Let's check. 4x times x, 4x squared. 4x times 5, 20x. Let's do another one. Okay, so this is pretty ugly. 36x cubed y squared minus 18x to the 5th y plus 24x squared y. What do you do? First, you look at the numbers 36, 18, and 24. What is the biggest number that can go into 36, 18, and 24 without a remainder? And the answer is 6. We could say that this is equal to 6. So that takes care of the number for the coefficients. Coefficients are your numbers in front of your variables. This is a coefficient, that's a coefficient, that's a coefficient. Okay? Now, what variables can come out? What variables are common to all three terms? For the x cubed, x to the 5th, and x squared. So the highest exponent for x that can come out is an x squared. I can't use x cubed because x cubed could not come out of this. That would be too big. I can't use x to the 5th because x to the 5th could not come out of that, and it could not come out of that. So that would be too big. However, x squared can come out of this, x squared can come out of this, x squared can come out of that. Let's go to the y. This is y squared. This is y to the power 1. This is y to the power 1. So we realize that we can take out y to the power of 1. That's the highest that can come out of all three terms. What do we end up with? There is a parenthesis. There we have our first parenthesis. Okay? If I factor out a 6, what number should go inside to get 36? The answer is 6. Because 6 times 6 is 36. Okay? Now x cubed is here. I have an x squared outside. So what must be on the inside? In order for me to multiply this times this to get x cubed, I must have an x to the power 1. I don't have to write the 1. Everybody in math world know that x by itself is x to the power 1. Without the exponent, we know that the default is 1. Let's check. 6x squared y times 6x will give me 6 times 6 is 36. X squared times x will give me x cubed. Now I have y alone outside, but here I have a y squared. So in order to multiply this, in order to end up with a y squared, I must have a y on the inside. We have a minus sign, so we put a minus sign. 6 on the outside, 18 on the inside. So what should 18 is the final result we need. So 6 times negative what gives me negative 18? The answer is negative 3. Then the x to the 5th, I have an x squared outside. So what should I put on the inside? So when I multiply by x squared, I get x to the 5th. The answer is x to the 3rd. I have a y on the outside, I have a y here, so I don't need anything here because I already only have y to the power 1. I already have y to the power 1 on the outside, so that's fine. Then we come to the last part. We see a plus, we put plus. 6 on the outside, 24 on the inside, so we know that we'll end up with a 4. X squared on the inside, x squared on the outside, so we know that we don't need another x inside because x squared times 4 will give me the 4. 6x squared times 4 will give me 24x squared. We have a y on the outside. We just need to get y to the power 1. So we don't need anything right there. So then the final answer would be that. Okay? So this will be the factored form. Truthfully, if you want to write it in standard form, this has a higher power than this. So we could write the negative 3x to the 3rd plus 6xy plus 4. Not a major thing. The most important thing I want to show you is how you can factor out the greatest common factor. So now we need to go to what we do when we have a trinomial, a quadratic trinomial. And now I'm going to show you what is needed. Okay. Okay. Look at it. You have ax squared plus bx plus c, where a, b, and c are numbers. A is a number, b is a number, c is a number. So this is what is called a quadratic trinomial. Okay? And we're going to focus today on only those examples where this is 1, when a is equal to 1. When a has a different number than 1, it's a different process. It takes a little bit more skill to complete that factoring. We'll do that on the next session. We'll do that on Thursday. Okay? So, what is the method? Step 1. Two numbers that multiply So we need two numbers that multiply to give you C, and when you add them, it gives you B. Okay? So step 2. Two binomials. So here it is now. All I'm giving you is a method, and then we'll do examples. You need to find two numbers that multiply to give you C, and when you add them, you get B. Again, A has to be 1. If A isn't 1, you can't do this. Find two numbers that multiply to give you this, and add to give you that. Put those two numbers in your parentheses to form your binomial. Okay? So let's do examples now. Okay. 1. If we had, say for example, x squared plus 7x plus 12. What are the two numbers that multiply to give you 12 and add to give you positive 7? So the two numbers multiply, you get positive 12. You add, you get positive 7. There are only two numbers that will work. Those two numbers are positive 4 and positive 3. It doesn't matter if you put the 3 and then the 4. It doesn't matter. The order is not important. As long as you have positive 4 and positive 3, you're good. Check it out. 4 times 3, 12. 4 plus 3, 7. Okay? I promise you, if you multiply these out, they will be equal to that. Let's check. Once you know that it works, you don't have to check. but I want to check to convince you that it works. X times x, x squared, x times 3, 3x, 4 times x, 4x, 4 times 3, 12. The two middle terms, we get x squared plus 7x plus 12. That's exactly what's over here. Another one. Again, this only works if you have 1 in front here. Your lead coefficient is 1. Notice we didn't have to write the 1 because everybody knows that x squared is 1x squared. Y by itself is just 1y. X by itself is just 1x. You don't have to put the 1. Everybody knows it's just 1. Okay? Two numbers that multiply to give me negative 14. And when I add them, I get negative 5. This comes with practice, okay? What are the two numbers? You multiply them, you get negative 14. So you know that for them to be negative, one has to be positive, one has to be negative. If when you multiply the two numbers, you get a negative answer, then the signs are different. Now, when you add them, you get a negative number, negative 5. So what two numbers to give you 14? Multiply to give you 14. We know 14 and 1 and 7 and 2. Those are the only two sets that would work. But one is negative and one is positive. Notice that when you add them, the result is a negative 5. So the negative number is the one that has to be the larger numeral. So therefore, it has to be the negative 7 and positive 2. Let's check. 2 times negative 7, negative 14. 2 plus negative 7, negative 5. If you expand this, I promise you, this is what you will get. Okay. Number 3. Okay, x squared plus 2x minus 15. So we know we can put our x, we can put our x. They multiply to give us a negative number. So we know that one is positive, one is negative. Of course, you could put the negative first and the positive after. It doesn't matter. What is important is which of the numbers you put the negative sign with. Because if you mix it up, you get a wrong answer for this part. Okay? So, what two numbers multiply to give us negative 15? Well, we know that 15 and 1, so that one is negative and one is positive, will give you 15, negative 15. But when you add those two numbers together, you will not get positive 2. So it could not be 15 and 1. What else do we have? Well, 15, 3 and 5. 3 times 5 is 15. So one of them has to be negative, one has to be positive. When you add them together, we get positive 2. So we know that the positive number has to be the bigger value. So therefore, we know that it's going to be positive 5 and negative 3. Starting to make sense? Good. Okay, let's try this one. 4. Let's use a different letter. Y squared plus 6y plus 9. Let's use a different number. We know that that's equal to y. What two numbers multiply to give you 9? When you add them, you end up with 6. So they multiply to give you 9 and add to give you 6. 9 times 1 and 3 times 3. 9 times 1 is 9, but 9 plus 1 is 10. It doesn't work. 3 times 3 is 9. 3 plus 3 is 6. Oh, so the answer is 3, 3, and 3. And of course, you could have written this as y plus 3 to the second power. Okay, and I have one last example for today. And then next class, we will go and do these where the lead coefficient is different from 1. That's going to be more involved. Okay, last question, number 5. Number 5. If we have x squared minus 16, what is that? Well, notice x squared, there's a quadratic, there's no linear, and there's a constant. So you could write that as x squared plus 0x minus 16. So we put a placeholder so that we could have the trinomial. There's no x, there's no linear term, so I put 0x. 0x is the same as 0. So this is the same as this. And now we can do our thing. It's x and x. The two numbers multiply to give us negative 16. So one is positive, one is negative. That's only you get a negative number, a negative product. The signs must be different. When you multiply, you get 16. When you add, you get 0. Oh, so all the negatives cancel all the positive. So we must have the same amount of negatives and positive. What numbers multiply to give us 16? 16 and 1, 8 and 2, 4 and 4. Well, 16 and 1 would not work. 8 and 2 would not work. So the answer has to be 4 and negative 4. Let's check it out. Check. X times x, x squared. X times negative 4, negative 4x. 4 times x, positive 4x. 4 times negative 4, negative 16. If you notice, negative 4x plus 4x, 0. So that's equal to x squared minus 16. These are very important. They are called difference of squares. We'll pick up next session as we discuss this. Thank you so much for joining us. And on behalf of the Brosis Foundation, we thank you for spending this time with us. And we hope that you found this interesting as we lay the foundation for higher level processing in mathematics. Okay? Enjoy the rest of your day. Thank you.